In this video, we'll talk about how to find the area between two curves. So suppose we have two functions. F of x equals negative 1/4 x squared plus 7. It's this upside down parabola. And g of x equals 12 over x. That's a hyperbola. And as it turns out, conveniently, these intersect at nice, neat integral values. They intersect at the points 2, 6 and 4, 3. And what we'd like to know is, what is this little area here? The area between these two functions. And so conceptually, the rule for this is very simple. The area between two functions is just the top function minus the bottom function between the limits of integration, which is often determined by the intersection points. In fact, sometimes in problems like this, you're given the functions and you have to figure out the intersection for yourself. Here I gave you the intersections already. So this would be, to find this area, the top function is negative 1/4 x squared plus 7. The bottom function is 12 over x. And we're integrating from x equals 2 to x equals 4. This integral should give us the area between the function. So the antiderivative of x squared is x cubed over 3. So combined with the negative 4th, that's negative x cubed over 12 plus 7x minus 12 times the antiderivative of 1 over x is log of absolute value of x. So all this evaluated at 2 and 4. Well, this is going to be, I'll evaluate each term separately. We have a negative 1/12, and this is 4 cubed, 64, minus 2 cubed, which is 8, and then a 7 times a 4 minus 2, minus 12, and then a log 4 minus log 2. And of course, log 4 minus log 2 is log of 4 divided by 2, which is just log of 2. And so here, this simplifies to negative 14 over 3 plus 14 minus 12 log 2. And so this is an exact expression. As it turns out, the decimal approximation is approximately 1.015567. And so this is an example of how to find the area between two curves. And conceptually, it's very easy, but I'll just point out that when we're talking about finding the areas before, we were talking about finding the area under a curve, and normally that is what that actually is just the x-axis, and then a couple vertical lines, and then just a single curve. So it's really a figure that kind of looks like a rectangle with one curvy side. Well, now that we're talking about area between curves, we can find the area of a truly bedazzling display of curvy figures with no straight sides whatsoever. And so that's what's so powerful about this technique of finding the area between curves.